Good morning everyone, my name is Johnny Ramirez. I am mechanical engineering student and in this video related to the subject of resistant materials. The professor in charge of the subject is Hector Dusan and today is March 20, 2023. Today we will talk about the principle of linear superposition, which is very important when talking about resistance of materials, going through its definitions and when we should apply incorrectly by means of an example. The superposition principle can be defined as the effect of the sum of actions is the sum of each effect of each action. Ensure that the effect of the sum is the sum of the effects. The superposition principle allows us to say that what happens in general to the intended beam is the same as what results from adding what happens to what same beam subject to each of the actions separately. That is, given the difficulty of calculating the first case, the being without the loads acting, we can solve two simple cases that we do know how to calculate and add. The principle is fulfilled and can be applied as long as the behavior of material is linear in exchange of materials to facilitate the assimilation of fundamental concepts. Linear materials or materials whose behavior we can simply as such, concrete, steel, etc., are normally always used. However, it is very important that the simplification does not lead you to think that it is an always applicable principle. Remember, it can only be used if behavior of material is linear. A clear example is in solid mechanics problems where the equilibrium equations say of a solid that is resistant and relate to the external forces on a solid with the internal stresses being linear. This means that for any solid that does no plasticity, if the value of the forces is doubled, the value of the stresses will be doubled. This happens regardless of the constitutive equations of the material, whether or not is elastic, as long as the final state does not depend on the mode of applications of the loads.